Get this into my content folder, select that folder, and I'm done with collision tests. Now in my assets folder, in textures, I have the crosshairs. And if I open them up, I can see what they look like. And we want all of these to be on the screen. Now, to put things on the screen, we have to use a special kind of blueprint called a widget blueprint. Widgets are HUD elements. HUD stands for heads-up display, and this is things that we see on the screen in video games that are in all games, things like progress bars, crosshairs, and what have you. So we need a widget blueprint where we can decide what to show on the screen. So to do that, I'm going to go to my blueprints folder, right click, make a new folder called UI for user interface. And in this folder, I'm going to make a new widget blueprint. I can do that by right clicking, scrolling down to user interface, and choosing widget blueprint. Now, when I create a widget blueprint, I have to choose a parent class, and the user widget is the class that we're going to derive from when we create widget blueprints. So I'm going to select user widget and call this WBP, short for widget blueprint, and call this W blueprints. So I'm going to select user widget and call this WBP, short for widget blueprint, overlay HUD. And this will be the HUD that we see on the screen when we're playing the game. And this will have crosshairs on it. So let's double click to open this up. And this looks a little different than an actor blueprint. It has a designer tab and a graph tab. The designer tab is where we design the widget blueprint visually, and the graph tab is where we can implement functionality. See, we have an event graph with nodes, much like the event graph in an actor blueprint. But we're interested in the designer tab, and what we want is the ability to drag images into our widget blueprint. Now, we can drag images in. We have a lot of different types of widgets in the palette panel. One of those is image. And if we drag that straight onto our event graph, well, we have this image. It's the size of the screen, and it doesn't have any specific texture selected for it, so it's just a white image. Image widgets have what's called a brush. And a brush is a structure that has a number of properties, including a texture called image. Now, if we select this image and open the image dropdown, we can choose one of these textures that we have for our crosshairs, such as the center. Now, this texture is now stretched across the entire viewport, and that's not exactly what I want to see. In addition to that, I want to drag multiple images on top of each other. I can't do that either. If I drag another image in, it'll show me that I can't just release and get another one. If I want multiple images stacked on top of each other, I have to use a type of widget called an overlay. Now we can search the palette for different types of widgets. We can find overlay and we can bring it in. Notice we have a hierarchy panel that shows us the widgets we have in our widget blueprint. But if we bring an overlay in, it's not going to let us simply drag it and drop it because an image is not capable of having things stacked on top of it. It's the overlay widget that allows other things to stack on top of it. So we have to delete the image and bring in our overlay first. Now that we have an overlay, we can start bringing in the images on top of the overlay. And notice that those images are no longer stretched. In fact, we can take that image, select it in the hierarchy, or select it in the designer graph, and we can specify whether we want it to stretch or not. We can do that under padding, where we see horizontal and vertical alignment. There are options to stretch it, or there are options to center it, or align it to the left, right, bottom, or top. We want center aligned both horizontally and vertically. And we can also go into our brush, into the image, and select one of our crosshair textures. I'm going to select crosshair center, and there it is, a tiny little dot. And it's right here in the center of the screen. And we can rename images in our hierarchy. And notice that they are attached to one another in a hierarchy. I'm going to rename this image to image underscore crosshair underscore center. And I'm going to drag in 4 more images. And as I drag them in, I'm going to drag them onto the overlay itself. I'm going to click on it and rename it to image crosshair left and change its image to crosshair left. Now it's all the way up at the top left by default, but again, under padding, I can set horizontal and vertical alignment to center, and now I have it right there in the middle. I'm going to do this for the 3 other widgets, and it shouldn't take long. All I need to do is drag in the image, rename it to image crosshair right, find the image crosshair right, set it to center, and there it is. Our next one, we'll drag it in, rename it to image crosshair top, set its image to crosshair top, set it to center, and one last image, renaming it to image crosshair bottom, setting its image to crosshair bottom, and making it center. And there it
So top center, the last one for the bottom. And compile.
it shouldn't take long. All I need to do is drag in the image, rename it to image crosshair right, find the image crosshair right, set it to center, and there it is. Our next one, we'll drag it in, rename it to image crosshair top, set its image to crosshair, renaming it to image crosshair bottom, setting its image to crosshair bottom, and here with one edit as separate textures. And if you want to get fancy, you can animate these and make them shrink or expand. But for now, this will work. We now have an image. All we need to do is add it to our viewport. Now, which class we use to do this? Well, that depends on our project and our preferences. You can do it in the player controller class if you have a custom player controller. There's even a class designated for heads-up display called HUD, automatically spawned in your project. But for our project, we're going to keep it simple and just spawn it for now in our bot pawn on begin play. So in our bot pawn here on begin play, we're going to create an instance of our WBP overlay HUD. To do that, we have to use a special node called create widget. If we call create widget, it's kind of like spawn actor from class, only it's specifically for widgets. And we can select the widget class from the dropdown. We're going to choose WBP overlay HUD.
Hey, okay, I think so. I found something. I forgot I have. I have to just check one thing. It's that India. As India or Asus product laptop. Okay, well, here I wanted two things. And ROG. This time I think so I'll go with the ROG. I'm damn pretty sure. Which graphics card I selected? 5060, right? Then why should I show me the 5070? Is that 5060? Yes. Laptop GPU. Is that 5060? Laptop GPU. Yes. Okay, I choose this one. What if I remove this one? Let us see. Uh-huh. 17 inches. I think right now. The same price actually. This is the one only with the AMD. Uh, 5060 and how much it's कितने जीबी का है ये बता मेरे को भाई ग्राफिक कार्ड हाँ 5078 अभी 8 जीबी बहुत है मेरे को 8 जीबी नहीं 6 जीबी चाहिए लैपटॉप के लिए ये बहुत ही है रेफरेंस 16 चल जाएगा वैसे लेट्स सी क्या है ये और अभी 6 में क्या डिफरेंस है रेफरेंस 6 चलो भाई लेकिन चलो लेकिन चलो वो एलईडी इज हियर भाई का मेरे दिखेंगे देना मेरा मेरे एलईडी डिस्प्ले नहीं दे रहा ये आईपीएस पैनल है फ्लो भी अच्छा है कनेक्शन एल्यूमिनियम वाली भाई ये तो हीट होगा ना फिक्स हाँ ये पूरा हीट होगा एल्यूमिनियम बॉडी है में एयर फ्लो ज्यादा अच्छा है ये जेल फाइव को भी सपोर्ट करती है इसका एयर फ्लो ज्यादा अच्छा है हम्म कैपेसिटी है तो फिर इसकी तो कोई बात है नहीं ये भी एड भी है ये भी एड नहीं भी है ये भी इतना है तो मेरे को इस पे ज्यादा कुछ लोड देना भी नहीं है Still local of global and type करूँगा RAM price. It's the RAM price.
widget. If you call create widgets, it's kind of like spawn actor from class, only it's specifically for widgets. And we can select the widget class from the dropdown. We're going to choose WP overlay HUD. We're going to go ahead and hook that up. Now we can give it an owning player, which is a player controller object reference. We're going to leave that blank for now. And we've now created a widget, but that's not enough. If we press play, we can't see it anywhere. That's because we have to add it to the viewport after we've created it. To do that, we take the return value, which has the type WDP overlay HUD object reference, and we call a function inherited from user widget called add to viewport. As soon as we do that, our widget will be added to the viewport, and we can press play, and we can see our crosshairs there. Now we still have a problem. Our mesh is right there in the center. Our crosshairs are in the middle, which is great, but our mesh is sort of in the way, right? So the last thing we're going to do in this video is move that mesh out of the way just a bit. Before we do that, let's give this a comment that says add overlay HUD to viewport. We'll give it a color and show bubble when zoomed out. And finally, let's move that mesh out of the way. Now, we don't have to move the mesh itself with that notebook.
Randomize. The rotation ये सब मेरे पे आई है.
And finally, let's move that mesh out of the way. Now, we don't have to move the mesh itself. What we can move is the camera. And instead of giving the camera an offset from the spring arm, that's not what I want. A better solution is to select the spring arm component and in the details panel, finding a property called socket offset. We can change the socket offset, and this allows us to move our camera but still be attached to the spring arm without a location offset. So if I take that third parameter of the socket offset vector and set it to about 45, now the camera will be raised a little bit, and we can press play, and we can see those crosshairs just above the mesh.
Okay. Let's see test. ये है अच्छा खासा बट ज्यादा ऊपर हो गया इसको थोड़ा नहीं. Hold on a second. Projectile moving speed. Ah, shit. वापस से नहीं है क्या मुझे काट दी ये यहाँ पे तीन ये आते हैं। हाँ ये रहा ना प्रोजेक्टाइल मूविंग स्पीड। ये तो सबका सेम ही है। एक सेकेंड इधर आ। और दो जीरो एक जीरो एक ही कर दे। हम्म, हाँ चलिए ठीक है। बेचारा रो रहा है।
A lot easier to shoot. Now, there is a slight annoyance, and that's that our blaster beams are not always hitting exactly what we're aiming at. It's kind of hard to play test with the BP bot shooting at us. So in the BP bot event graph, I'm going to find fire blaster beam and just disconnect that node for now. So it's no longer firing at us. Now I can play test without getting shot. And now if I shoot my blaster beams, notice that they're going straight forward. And my mesh is not exactly aligned with my crosshairs anymore. So I'm not going to hit what I'm firing at. I have to overshoot a bit if I want to hit that bot. So how can we have the best of both worlds, where our crosshair is not being blocked by our mesh and we can see what we're shooting at, but also make sure our blaster beams hit precisely what our crosshairs are aiming at? Well, we're going to do exactly that in the next video. I'll see you soon. Welcome back. So our shooting mechanics are looking pretty good, but there is a small detail. When we shoot, our projectiles are going straight forward, and that means that they're not exactly hitting what we're aiming at. If I'm shooting at this bot here, my projectiles are going under the bot, and that's not exactly what I want. What I want is whenever I shoot, whatever my crosshairs are aiming at, I want my projectiles to hit that exact location. And to do that, we can make use of line traces. Now, we've used a line trace in the previous section when learning about collision. Line traces are a useful utility used very commonly in game development. Now, the way we can use a line trace is whenever we shoot a projectile, we can perform a line trace.
Uh,
Straight out into the world from the center of the screen outward. If we perform this line trace straight out into the world, then that line trace is going to hit whatever we're aiming at, whatever's underneath the crosshairs, provided that those crosshairs are exactly in the center of the screen. If we do that, we can then get a hit result from that line trace. And the location of the hit is going to be something we can orient our projectiles toward so that they fly in that direction and hit exactly what we're shooting at. So let's do this line trace. We're going to do it from our bot on. And we can do it when we fire the rifle. So what we'll do is we'll go into our fire rifle function here. And the first thing we're going to do is perform a line trace. And we'll do for everything else. That means before this branch as well. Now we can move that purple input node back and make room for the line trace nodes. But I really don't want this red wire going behind our nodes and crossing with things. So what I'm going to do is right click and use a get node for is left rifle, this input parameter here. It's an input to the function, therefore we can use a get node for it. That way we don't have any wires crossing. Now that we've made some room, let's do a line trace by right-clicking and searching for line trace. Now we have multiple line trace options here. The one I'm interested in is called line trace by channel. This performs a line trace, and much like objects in the world have their own collision object types, which is a collision channel, a trace also has its own channel. Line traces can only use trace channels and not object channels. And in our project, we only have two collision trace channels, visibility and camera. By default, the trace channel is set to visibility, which means we're going to get a blocking hit on any component in the world that has collision data and is set to block the visibility channel. Now, we want to get a line trace hit on static objects such as the floor and walls and things like that in the world, but we also want to get a blocking hit on the bots that might be flying around in the world, our BP bot drones. Now, we can remind ourselves of the collision settings of the bot by going to BP bots, finding the bot mesh, and scrolling down to its collision presets. We see that we have enemy mesh here. And enemy mesh is, by default, to ignore the visibility channel. So if we're going to use the visibility channel for our line trace, and we intend on hitting the mesh for BP bots, then we need to change one of two things. Either we need to trace against a different trace channel that the bot mesh blocks, which there are no trace channels that the bot mesh blocks, so we have to go and make a new channel, or we trace against the visibility channel, and our BP bot mesh blocks the visibility channel. Either one of those will work. And in serious games, usually a custom trace channel is created specifically for line traces associated with weapon attacks. So we could create a custom channel called weapon, for example, and trace against that, and our BP bots could block that. So there are different ways to go about this. To get things working, though, we can simply make our BP bot block the visibility channel, and then we'll get trace hits if our line trace actually hits a BP bot's mesh. So to block the visibility channel, we need to change the collision preset enemy mesh. We do that in project settings. So we can go to Edit, Project Settings, go to Engine, Collision, and under the preset dropdown, we can scroll down and find our custom enemy mesh. Now, I don't see it here, so I'm going to click on something else like Cinematic Camera and come back to Collision and scroll down, and there it is. It's a weird quirk with the editor. But I can find enemy mesh, I can select it, I can click on Edit, and I can choose to block the visibility channel for enemy mesh. As soon as I click Accept, I can come back to BP bots, and I see that visibility has a block response. So now that we've taken care of that, we can go back to our BP bot pawn and configure our line trace. Now, the trace start is going to be at the camera location. This will ensure that our trace begins at the middle of the screen, as the camera has a location at the center of the camera itself. So we can drag out and get our camera component, and we can use get world location. This is a function that belongs to the scene component class, and a camera inherits that function as the camera component is derived from the scene component. So it has that function. And that's going to be the starting point of our trace. But to visualize this, I'd like to draw a debug sphere so that we can kind of get an idea for this location in the world. So I'm also going to draw a debug sphere at the location of the camera. So we're going to hook that into the center. The radius for the sphere will be small, so 5. Color can be a red, and duration can be 60 seconds. So we can go ahead and connect the wires to draw a debug sphere. And the camera world location is going to be the starting point for the trace. So I'm going to copy these nodes and paste them over here where we're doing the trace and hook that location in to the line trace. We can also hook up these wires as well. So we're starting our line trace at the world location of the camera. The ending point for the line trace is going to be straight out in the forward direction of the camera. So let's make that trace end location. So we'll take the camera's world location, I'll copy those nodes, and we're going to add to this vector. And what we're going to add is the camera's forward vector. We're going to get that camera's forward vector by using get forward vector. This is another scene component function. And forward vectors are typically unit vectors. They have a length of 1. So we need to multiply this forward vector so that it's longer. So I'm going to multiply and convert the second pin to a float. And this will be the trace distance. This will be how far our trace will reach out into the world. Now, this can be a variable. So I'm going to drag off and promote it to a variable, not a local variable, but a variable on the bot pawn itself. And this could be the trace distance. So I'm going to call this trace distance. It's going to be a float. And I'll go ahead and give it a category in the details panel. I'm going to make this category combat. And I can compile it. This trace distance a default value. Now this can be a large value, something like 5,000. So we have the forward scaled by 5,000. And if we add that to the world location, then we get the end location of that vector. In other words, the location pushed out from the camera in the forward direction by 5,000 units. And we can visualize that by drawing a Devo sphere at that location. Now I'm going to take this location and promote it to a variable. And this one will be a local variable, local within the scope of this function, because we only need to use it inside this function. And I'm going to call this trace end. So the trace end will be where we stop. Trace. Anything beyond that point is out of reach of our line trace. So we'll go ahead and hook that up. And I'd also like to draw a Devo sphere at this location as well. So I'm going to copy my draw Devo sphere node and hook up the trace end as Now this one can be a little larger because it's going to be farther out. I'll give it a radius of 20, and the line color can be a slightly more orange color. So we'll hook this up. And for our line trace by channel, we'll go ahead and use the trace end for the end location of the line trace. Now for the line trace, we're going to trace against the visibility channel. We don't want to trace complex. I want to trace against simple collision only. For draw debug type, we're going to draw a debug for the line trace so we can see a debug line and a point and see if we got a hit. So we're going to draw a debug for duration. And if I expand the dropdown, I can change the trace and hit color or the trace color. I'm going to leave those as is. And for the draw time, I'm going to set it to 60 seconds so it lingers around. Now, if we want, we can input an array of actors to ignore for this trace. But there's also an ignore self boolean, a nice convenient setting that allows us to not have to worry about this particular actor being hit by the line trace. The bot pawn does not want to hit itself with the line trace. So we'll use ignore self to prevent that from happening. So right now, all we're doing is a line trace and drawing debug spheres at the start and end locations for the trace, as well as a debug for the trace itself, which will consist of a line and a debug point. Let's go ahead and play test and see how this line trace behaves. I'm going to go ahead and press play, and all I need to do is fire the weapon a couple times. I'll just fire it once. And if we look behind us, we'll see the location of the camera. Remember, the camera is just behind our mesh and up a little bit. And our line trace goes straight into the world, and we got a hit on the floor. That's that little square there. That's a debug point. Now, we could go beneath our floor and see that our line trace extended out quite far. Remember, our trace distance is 5,000 units. And there's our second debug sphere, the larger one, with a radius of 20 at the trace end location. So we have a trace end and we have a trace hit point. That's the point here where we actually got a hit by the line trace. Now let's trace against our BP bot actor and see if we get a hit when we're aiming at the bot. And sure enough, we did. We can see our line trace debug. We have a red line up to the hit, our debug point drawn at the impact point, and of course, our line trace continues for 5,000 units, and the debug just shows it in green. Now, these little small spheres are kind of getting a little distracting, aren't they? So I'd like to get rid of that actor, our sphere spawner, and we can also edit that sphere spawner so that that spawn time is not quite so short. I'm going to set it back to about 2 seconds, compile, save that, and close it. And I'm also done with the sphere spawner in this level, so I'm going to go ahead and delete it from the level so we can test a little better. Okay, so we know that our line trace is hitting what we're aiming at, exactly what we're aiming at. We can tell by taking a look at those debug points and seeing that they're appearing exactly at our crosshairs screen location. But we're getting a 3D space location, and that is something we can aim our projectiles at, so they always hit what we're aiming at, and we can stop missing like we're doing now with our blaster beams. So the next piece of this puzzle is to orient our blaster beams. So let's go back to our bot pawn and decide how we're going to use the information from our line trace. Now here's the thing, our line trace may or may not get a hit. We won't get a hit if our line trace doesn't hit anything. If I aim up at the sky, for instance, well,
Oh shit, man. Okay. I need a little small break. My leg is.